नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर IT JEE एंड नीट. This is episode 2 of concentration cell, and in episode 1 we have discussed that for a concentration cell E0 cell is always 0. The second point was for the spontaneity of the cell the reaction quotient is less than 1, and the third point is how to decide which electrode will be anode and which electrode will be cathode. In the second episode we are going to discuss that the concentration cell is used to determine the KSP of sparingly soluble compounds. The second point we are going to discuss is the concept of concentration cell is used in ECG, electrocardiograph, and the third point is working of concentration cell is entropy driven process. Let us start with the first application of concentration cell. Concentration cell is used to determine KSP of sparingly soluble compound. So here one cell diagram is given in which the left hand side electrode is Ag solid, Ag plus in saturated AgI solution, and the right hand side electrode is Ag plus whose concentration is 0.1 molar and Ag metal. So on the left hand side it is metal ion half cell, and on the right hand side also it is the metal ion half cell. Since the metal and metal ion is same, it is an example of concentration cell. So this cell is concentration cell because both the electrodes is same. Now some of the students get confused about this left hand side electrode because there is a metal and there is a sparingly soluble compound. So there is an electrode metal insoluble salt anion half cell, but this is metal ion half cell because in metal insoluble salt anion half cell there must be three chemical species. One is metal, the other is insoluble salt, and the third one is a chemical species which can apply common ion effect for the anion of the sparingly soluble compound. So if along with AgI, if Ki is there in the solution, then we'll say that it is metal insoluble salt anion half cell. But here since metal and metal ion is there is no common ion effect, so it is metal ion half cell. So if it is a concentration half cell, we know that for concentration half cell E0 cell is always equal to 0, and they are saying that the EMF of this concentration cell is equal to 417 volt. Let us go through the diagram of concentration cell. The left electrode is anode and the right electrode is cathode. There is a saturated solution of AgI on the left hand side. So we know that if this left hand side electrode is anode, at anode oxidation will take place. If oxidation will take place, Ag metal will dissolve and come into this solution in the form of Ag plus ion, and the electron will reside on this metal plate and they will move from anode to cathode. So with time the concentration of Ag in the solution is going to increase. So the concentration of Ag on the left hand side is going to increase with time, while on the right hand side this Ag plus ion is going to take electron to deposit on this metallic plate. So the concentration of Ag plus on the right hand side is going to decrease with time, and this is the way how concentration cell work. On anodic compartment the concentration will increase, on cathodic compartment the concentration will decrease till the concentration in both the compartments will be equal. So here if I compare that, what is the concentration of Ag plus initially in the anodic compartment, since in the cathodic compartment the concentration is 0.1 molar and it is decreasing, and the concentration of Ag plus in anodic compartment is increasing, we can say that initially the concentration of Ag plus ion in anodic compartment should be less than 0.1 molar, and it seems to be correct because it is produced by AgI. AgI is a sparingly soluble compound, so the Ag plus ion produced by AgI in this solution will be very small. At anode, Ag solid is converted into Ag plus by loss of one electron. At cathode, Ag plus will accept an electron to deposit on metallic plate. If we see here, the electrons on the left hand side and right hand side will cancel out. Ag solid on the left hand side and right hand side will be cancelled out, but we cannot cancel the concentration of Ag plus ion in anodic and cathodic compartment because they are different. So the reaction quotient can be written as concentration on the right hand side, that is concentration of Ag plus in anodic compartment divided by concentration of Ag plus in cathodic compartment. Since Ag plus in anodic compartment is coming from AgI, that is equal to solubility of AgI upon, it is given that the concentration of Ag plus in cathodic compartment is 0.1 molar. So from there we are getting that reaction quotient is 10s, and we know that for a concentration cell to be spontaneous, Q should be less than 1. So this 10s value should be less than 1. Since we know that E naught cell is equal to 0, by using Nernst equation we can say that EMF of the cell is equal to 0 minus 0.0592 upon 1. This is valid at room temperature. Log reaction quotient. On putting the value and solving it, since in the question they have mentioned that EMF of this concentration cell is 0.417 volt. So if we take 0.0592 on the left hand side, this minus sign on the left hand side, and simplify, then we can say that log 10s value is equal to minus 0.417 divided by 0.0592, and on further simplification we can calculate what is the value of solubility, which is coming 9.04 into 10 to the power minus 9 mole per liter. Since it is a saturated solution of AgI, this is the equilibrium. There is an equilibrium between AgI solid and Ag plus in aqueous and I minus in aqueous. For this equilibrium, we can write that Ksp is equal to solubility square. Since we know the value of solubility, we can find out the Ksp. So on solving, we are getting that the value of Ksp is 8.17 into 10 to the power minus 17. Like AgI, we can calculate the Ksp of AgBr, we can calculate the Ksp of AgCl, and many sparingly soluble compounds with the help of concentration cell. Let us try to understand the concept of concentration cell in ECG. ECG means electrocardiograph. A biological cell is compared to concentration cell for the purpose of calculating its membrane potential. So first we have to understand that what is the meaning of membrane potential. A membrane potential is established when there is concentration difference of the same type of ion in interior and exterior of a cell. For example, potassium ions in interior and exterior of a nerve cell has concentration of 400 millimolar to 15 millimolar respectively. Treating the situation as a concentration cell and applying Nernst equation at the body temperature 310 Kelvin, we can calculate the membrane potential. So before calculating membrane potential, here this is the diagram shown. So this is inside of the cell and this is outside of the cell. Inside of the cell, the potassium ion is represented by rectangle. So these ions are more inside of the cell and the concentration of potassium ions are less outside of the cell. So because of the concentration difference of potassium ions inside and outside, since same ion is there inside and outside, there is a development of concentration cell. So let us try to calculate the potential of this concentration cell. So we are saying that interior cathode. Why the interior will act like a cathode? Because we know that in concentration cell, where the concentration of an ion is more, it will decrease. So since interior potassium plus ions are more, the concentration is 400 millimolar. So it is going to decrease. And in exterior, the concentration of ions is going to increase. So if this is working like a concentration cell, E naught of the cell is equal to 0. By using Nernst equation, since the temperature is 310 Kelvin, if we calculate the value of 2.303 RT upon F, we are getting this value nearly 0.06. So EMF of the cell is equal to E naught of the cell minus 0.06 upon 1 log concentration of K plus ion at anode. So exterior is anode, so its concentration is 15 millimolar, and concentration of K plus ion at cathode whose concentration is 400 millimolar. So now if we simplify this value, we are getting this value is minus log 15 by 400 is minus 1.42. On simplification, we are getting that the EMF of this concentration cell is equal to 85 millivolt. So because of the concentration difference, a potential is developed. That potential is known as membrane potential. So what is happening during a heartbeat? The concentration of potassium ion in interior and exterior of the cell is going to change. During the heartbeat, the membrane potential drop from 85 volt to 35 volt, because when a heartbeat will be there, the potassium ions from interior will go exterior. Before that, the potential difference was 85, but when the potassium ion will go in exterior, the potential difference decrease and it will become 35 millivolt. So the sudden change in potential is known as action potential, and this action potential produce enough current to be detected by the electrodes placed on the chest, and these electrodes are silver chloride electrodes because they are inert in nature. The amplified signals can be recorded, which is known as electrocardiograph. So this is the application of concentration cell in ECG. So let us discuss the third point. Working of a concentration cell is entropy driven process. So this is an example of a concentration cell where the anode is made up of iron metal and iron plus 2 ion is there, and the cathode is made up of iron metal and iron plus 2 ion is there. So we know that for concentration cell, E naught cell is equal to 0. And we also know that in concentration cell, the dilute solution will become concentrated and the concentrated solution will become dilute. So during the working of the above concentration cell, the concentration of the iron ion will be increased in anodic half cell. You can say that in the left hand side, this is anodic compartment where the initial concentration is 0.01 molar. And with time this is going to increase, and the concentration of iron plus 2 ion will decrease in cathodic compartments. On the right hand side, initial concentration is 0.1 molar. With the working of the cell, the concentration of iron plus 2 in the cathodic compartment is going to decrease. Since cell is spontaneous in working condition, the spontaneous change in the concentration cell always occurs such that concentration solution becomes more dilute and dilute solution become more concentrated. Final resultant is if the solutions were simply mixed, because on mixing of two solutions, the dilute solution's concentration will increase and the concentrated solution will become dilute solution. This effect in concentration cell is like mixing of two solutions, and since these solutions are dilute, we can assume that these are mixing of two ideal solutions, and we know that on mixing of two ideal solutions, delta H mixing is equal to 0, and mixing is an spontaneous process, so delta G mixing is negative and delta G is equal to delta H minus T delta S. Since delta H mixing is equal to 0, we can say that delta S mixing is positive. From this we can say that working of concentration cell is entropy driven process. There is another way to say the same thing, because we know that change in Gibbs free energy of system at constant temperature and pressure is equal to minus T delta S total. So this formula is valid at constant temperature and pressure, and this is relation between change in Gibbs free energy of the system with entropy change of the universe. So we know that when a concentration cell is working, it is a spontaneous process, so delta G, because EMF of the cell is positive, so delta G of the cell is negative, and from there we can write that delta S total is positive. Since it is mixing of two dilute solutions, so we can assume that there is no enthalpy change, there is no exchange of heat energy between system and surrounding. So delta S total is equal to delta S system plus delta S surrounding. We can say that delta S surrounding is equal to 0. So delta S system is positive. So there are two ways to say the same thing. And this concept is asked in a multi-correct question of JEE 2022. So the question is, the correct options about entropy change is R. The B option is the cell reaction. Here if you see, the left electrode is hydrogen gas and hydrogen ion, and the right is hydrogen gas and hydrogen ion. So it is a concentration cell. So they are saying that the cell reaction is an entropy driven process. So for concentration cell, the cell reaction is an entropy driven process. For more videos, please like and subscribe and share these videos with your friends. Thank you.